Now, today's topic is we are going into composability and component in Starknet. And before I start this, just say that you are like me. You don't like typing a very just say like yeah, like me. Can you hear me? I'm sure you can hear me, right? Okay. Just say like you're like me now and you want to maybe type I don't know how many people are very versatile in Web2 here, or actually typing good quality codes. But you're like me that's any little line of code, let's say two lines of code now, that might be repeated in many places. I would like to extract it and put it out in maybe a separate function and use it in those places that are needed. And now Cairo has a problem. It seems that Cairo does not store. I think in week 1 we were told that Cairo does not store states, does not have a storage states, but Starknet has. So there was a way that the person that whoever invented Cairo and Starknet smart contracts found a way to break it down. I think there are front end developers here that are used to making components, that is React components. So that if you are going to make a card components now, you can reuse those cards into different places. Yes, so these are two things now. One is that these components, you can reuse them, yes. And you can split up your contract into different components. Let's say your contract is very long now. I know what you have done so far is splitting up your contract into an interface and into a contract. But then there are some contracts you may write in the future that will have so many interfaces. Let's say 6, 7. You split that one into different files, and now you have to write a contract. Maybe it's a very big contract, maybe online store or something. You cannot start writing 2,000 lines of code. Yes, I know that most of you love writing 2,000 lines of code inside one file. That means you are not like me. But me, I love highest 50 lines, 100 lines. You move on to the next file. So I like splitting it up so that at least you know what you are doing. You see what you are doing. Of getting confused by too many codes. So now these components now make that kind of thing possible. There are Lego-like building blocks for smart contracts. Developing contracts with shared logic and storage can be difficult and error-prone, as the same functionality often needs to be re-implemented in each contract. However, components offer a solution by providing modular, reusable add-ons that encapsulate logic, storage, and events. These components can be easily integrated into multiple contracts and blah, blah, blah. You can take a look at these slides. I know most of you love slides here. Although I don't really see most of the things you are doing in this week will be typing code. I can't wait to finish this slide version here. So now there are components now, like you wrote ERC20 contract, right? If I switch to this screen, if you just react, I think yes,
sir,
very good. So you wrote ERC. Okay, sharp. So you wrote ERC20 contract now. And now, have you ever thought that you were the only one that wrote it? I know Lamin wrote it, Shoma wrote it, Oluwatobi wrote it, KK Mane wrote it. Yes, many people wrote it here. Yes, good. But then before you, there were like millions more that wrote it. And you just ever thought of it like, why will 4 million people keep writing the same thing? So there was a very smart person among the early adopters that said, no, he wants to take this thing out. He can't let these people keep writing these things. He wants to extract it, like how I used to extract my own. So he made a component and he put it. I don't know if you can go online, check out Openzeppelin. I think I'll send the link. I'll send the link. I think even here. Hello. Yeah. I know you have, I'm not sure if you have seen this kind of thing before, but most of the times you are going to be using this. And as you are coding, I'll show you how real life coding looks like. I know most of you have coded now, so most times you ChatGPT, you get. I know most of the times you don't want to say it out, but me, I understand because me too, I used to use it. So you go around, you search. There are some things that you might not know. You have to just go and search. You can go to your previous repos, go to other people's repos, check, copy, paste, and the rest. So this Openzeppelin now, they made it easy. Like one of the things that they did was implement an ERC20. So you don't need to just keep writing all those functions, transfer from blah blah blah. Just go right here and pick it up and paste it. But we get to that, don't worry. Now unlike your contracts, components are different. Yes, they have storage states, they have storage, they have events, they have interfaces, yes. But the difference between a contract and a component is that you can deploy a contract, but you can't deploy a component. Component is like a parasite. It has to latch onto something, which is the contract. So if you make a component, it's basically useless until someone uses it in his contract. Now, although you think if you want to test your components, you get to testing later. Maybe on Friday, I can take you on testing components individually, like picking out the component and testing it. If the component is working before implementing it into your contract, yes. And because components cannot be deployed, it does not have a constructor. It's how it is written. It's much more. I just believe now by now that I just believe by now that people should know how to write contracts by now. I heard that if you still have, if you want to do it tomorrow class, write contracts, like you should have been done with all these things. So contracts, you should have been done with it. You wash your hand, you keep it aside. You have through with contracts, you have deployed contracts, fine and good. You leave it there. Mental components. Components, it has one kind of there's how this to write it. I had to even learn it again today. So that belong of written a component. But most of the times you won't write the component. You'll be using the component. Yeah. So unlike contracts, components are standalone and can't be deployed separately. Instead, their logic becomes part of the contract bytecode when embedded. Yeah, they are embeddable. So definition of a component is very similar to a smart contract, like I said. It can contain storage variables, events. Actually, if you want to write list of functions that don't store states, you don't need to make a component. There are some files now that I've written in the past that you write in the future that it just does a logic calculation and returns your value for you. And there's I don't know if you have taught you guys about traits and implementation of traits on structs. So although I learned this new but most people are still learning it. You make a struct, then most of your internal functions now that are meant to be in your contracts. If it isn't reading from the storage, maybe it's only. So how do I want to explain this now? I should my vscode. If the first parameter to your contract function is wait, let me go back here, yes, in case you have questions. So you know that the first parameter of your contract function is a self. Wait, maybe you should react first. Let me see if I'm talking to myself. Okay, you are good. So the first parameter to your contract function is yourself. Then ref or maybe a snapshot. Snapshot you call it. Your ref or your snapshot, yeah. But there are sometimes that you have that ref, maybe in your internal functions. I don't know if you have written internal functions, but there's one that's the API. You expose it to whoever wants to read it. Then there's one that is internal function, which you only use in your contracts. You don't want anybody to use it. Yes. So those internal functions now, they have the first parameter, which is yourself, then some other parameters that are not yourself. So let's say that function now wants to do a logic, and it does not read from the storage, because that self actually is something that can read other functions in that contract and your storage, self dots, whatever is in your storage dots read. Now, if that function now is not reading anything from your storage, or it's not reading any other function in your contract, then it should be an external function, yes. Because now, if you are doing such a thing, I think it's not good practice actually, but you may come to terms with this thing I'm saying, Sha. Right now, if I say as I've said it, you forget it. Then 3 months later, you now remember it and say, okay, there was one man like that said something, that kind of thing. So what else? Yes, that it has storage variables, events, and external and internal functions. Yeah, just like your contract that you have, most of you have written. And yes, these internal functions now can be called by the contracts, by the components, yes, but cannot be called from outside. And yes, when you're writing your components, you don't expose anything as API. That's API extend, API embed not. Yes, that v0 stuff. You don't do it on components. So next, creating a component. Yes, just like your contracts, you start by saying Starknet contracts. Component, you just change the contract path and components. Then public mod, whatever you want to name your components. Yes, this conversion is very good. This conversion is very good. Yep. Defining the component in the interface. This thing looks familiar, right? You have written this kind of thing before. It's just basically your contract interface, but this time I see it for your component. And you need this interface. Like normal, you separate your interface from your contract. Put it in a separate file. Now this interface now will be what your component will implement this trait. Once you implement this trait, it will be embedded in your contract. Then your contract will expose these traits. So whatever your components implemented as an API, using your API embedded VNodes. Don't worry, all these things are confusing. I know. But you see it in code, you see it in receipts. So once your contract embeds that component, then what you used to call the embedded components API, contract exposes is through your interface, this trait. And of course, it has to make a dispatcher for you. Yes, over here. This stuff over here to make a dispatcher for you, so you can actually call your contracts, your components that's embedded in your contract. Yes. So this is just your basic layout of your components. And this, okay, no, it's not. This is, yes, this page, this slide, and this slide. I don't know if you're going to screenshot it, but this is what will help you in the future when you're writing assignments. My assignment is hard, not that one that has scoring 90 over 100. There's how my assignment is. You have to, you will get there. You get there on Friday. So it's for your own good, actually, Sha. For your own good.
Excuse me, sir.
Sir?
I believe you have a slide for this lecture.
Yes, that's what we are. Can't you see my screen?
No, like the link to the slide.
Oh yes. Yes.
Instead of me trying to screenshot the.
Okay, because the link is like going too far, yes, but you should just go to your pictures and just see. But yes, the link has been dropped already, so you can check it out after the class. Yes, so so yeah, this is what you'll be using. This template is what you'll be using throughout your whole component building. Yes. Just these components. We have your storage. Yes, you know what the storage is. We have the events. Yes, your component also those events. It's just basically a contract, but something that can be reusable. Then we have, yeah, this is an event. This is an event. Now, this is the main part of it. This is this actually is the API. This, I don't know, can I highlight it? No? But actually, this is just what you're going to embed as the API. You get there. If you have any questions, Sha, you have any questions, you can just. This is question session. This is question session. So if you have any questions, just Moses. All right, Moses, let's hear your question, please.
Okay, good evening, sir.
Yeah,
Can you hear me,
boss.
please?
I can hear you clearly.
Okay. All right. Coming from Solidity, I know that the ABIs are just like a skeleton of the functions and everything that a smart contract will have. So from the component you showed now, that means all those things there are more like functions, right?
You mean this, right?
Yes, yes.
Yes. I've seen some Solidity code, and I don't know how the split up the files, but I'm very sure that they don't have any structs. They don't have anything that they used to like that is Cairo storage. That's their macro storage, blah blah blah. Their storage is basically written like your normal. I don't know if JavaScript has storage. I type Java, so I know Java has storage. Just type it. I think it's uint 255 blah 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 blah. So if you look at Solidity and Cairo structure of how they are coded, it's far different. Although I've not coded Solidity before, but I've seen it. Yes. So if you just keep Solidity aside, and just know that your component is just basically like your contract that you have been writing. So yes, you are correct. Under this implementation, you see this embeddable as this implementation here. Everything inside this implementation block will be all your functions, all your APIs. So yes, you are correct. So I don't know if I answered your question. No? All right.
Yes,
so,
you did.
Your
Thank
last
you.
question. Okay. You're welcome. So I know Lamin, you have question now, right? Something you want to ask me. Lamin, have you slept?
No, I'm not sleeping. Well, I'm trying to conceptualize what you said. And so to me, it's like those components are kind of library components, right? Like in other languages, when you want to make use of a library, you pull in the component by either using import or
Yes.
whatever. So that's how I see, that's how I assess this component thing.
Sharp. Choma, you have something to say? Yes, I know you have something to say. Hello?
Hi. No, I don't.
Okay, don't have
sorry, I have something to say. So the components, are they like normal components like in Like, okay, let's say like React, for example, right? That contains stateful logic and everything. And can they be reused?
Yes, that's why there are components. That's why they call it components. It can be reused across many contracts, even your own contract and even outside your own contract. You can even like create it like what Lamin said, like a library.
All right, thank you.
Yes. So I think that's all for now. Let's proceed. So what is this on? I think it's the end of my slide. It's the end of my slide, yes. So it's just basically what a component should do. I have other things here. You know, you don't need to see this screen. Now I think you guys know what just the basic rough idea of what a component is, right? So we are good to go. We can start writing our components, right? Okay. Sharp. We're waiting for you guys. Yes. So let me open my VS. What are we going to be doing? Yes, we're going to make your ERC20. We're going to make an ERC20 contract. But we're not going to do it that way that your last tutor did it. Because, like I said, that I'll call it like wasting time. Well, it's if you actually read some algorithms also, they will tell you how to implement maybe sorting an array, quick sorts, what else again? Merge sorts, and some other algorithms. Yes, but it doesn't mean that those algorithms are not already made already. But they're just like trying to tell you that okay, yes, this is how it works, so that you can get conversant with it. It will actually improve your experience. So yes, the activity you guys made last week increase your experience if you guys actually made it. But this time it just make you have good code quality. So now the first thing now we are going to do now is make a token. You can type the name of the token in the contracts in the comment section. And actually, when you see people making tokens, you go and farm your airdrops. So actually, the tokens now they make it under just few minutes. You think you just want mad something, but it's just some numbers. I'm very sure you know. Okay, leave smart contract guys now. You people consolidate. You should calm down. Now we have two guys. You know how a token works, right? Like just numbers. You know that. Just mass minus this plus this going on in the contract. So if the good guy has 30 tokens, yes, it's not that he has something like your normal coin that is individual. You know, it's just 30, basically 30 that I typed. But anyways, the contract is just like it's a contract that stores users, people that hold the tokens now. The contract stores it in storage. So to you now, it's as if you are storing the token, but in reality, like, the token is storing you and your details. Well, you get back to that or not. So let's go here. So if you can go to your link, you go to this message here, you see a link I sent. If you can't see the link, you can specify, can we send it? I don't know if you can see my screen now. So you can open your terminal. Yep.
So, okay.
Hello? You have something to say?
Yes, we can see your screen. No. I was not seeing your screen that time. Sorry.
Okay. Let me open my terminal. You can see my terminal, right? I've forgotten how many times I increased this hardcore. Can you see my terminal?
Yeah.
Okay.
Yes.
So your normal Scarb new. I don't know, I've not tried it for a long time, so I don't know if how it's working. Let's check.
Please, can you zoom in? Can you zoom in the terminal, please?
Wait, you can't see this? Should I still zoom in?
Yes, sir. Please zoom in because I just went to YouTube today for the recordings of the other classes, and the code editor were small. I don't know if it was from my eyes or what.
No. It's definitely not from your eyes. It's from the. Okay, let me try and zoom in like. Is it okay now?
Yeah, better now, better now. Thank you.
Yeah, it's okay now. It's okay now.
Sharp. Let's go. So, Jesus. Okay, yes. So let's go into. Let me check this new. MTM, please. What? Very good.
Sir, excuse me. We are creating a new project, right?
Yeah.
Hello, sir. We are creating a new project, right?
Can you hear me?
Say we are
Yes, you are creating a
new
new project.
Okay.
Can you see my ID, my vscode screen? Is the size all right? Check. All right. Okay. One more person. I just know that you are. Prince, what are you thinking? Yes. Good. So you are good to go, right? I just hope you are with your laptop, Sha. And I hope as I'm typing, yeah, I hope. Well, let me just be open. So let's try to create a token. How do we create a token? I think you have created it for us now. So we should create this token in, let's say, let's give ourselves 20 minutes. All right. So let's create a new.
Sorry, excuse me, sir.
Yep.
Hello, okay. Sorry, sir. I want to just ask a question. Hello, can you hear me?
Can you hear me?
Yes, I can hear you. I want to just confirm something. You know, the last week classes
Okay.
so they actually did they actually wrote the AROC 20 contracts. So no, I'm still going over the videos of last week, and I've not actually gotten to that part where they wrote the AROC 20 code. You understand? So I want to know, like, this class, these components now, like,
Okay.
me not like, because of unforeseen circumstances and system issues, so I couldn't follow up with the class live. So I'm actually going through the videos online. So I want to know, like, me not um writing the code with them, yeah, so it will really affect my understanding of this class. Like, this component does it have anything like to do with the AROC 20? I want to just know.
Have you written a contract before?
Yes, from the previous class, like the contract you wrote them from like the last 2 weeks.
Okay. I don't know whether it will affect you or not. If you're like me, it won't affect me actually, Sha. But then that's why I said something about um algorithms. They will teach you on how to write algorithms, sorting algorithms, and maybe um what else? Which other algorithms I think, and some kind of data structures, how they work. It's not that it has not been implemented before. If you know how to use it, fine, you can go and use the algorithm that has been implemented maybe in Python or Java or whatever, or in TypeScript library. But why some people learn it is just to gain experience on how it actually works. So that if you are doing I don't know if it will affect you, because after these components now, you might be writing your own contracts, and you may actually want to do some transactions with tokens in your contract. And now, if you're
Okay.
like me, actually, if can you hear me?
Yeah, I can hear you.
Yes,
Can
if
hear
you're
you.
like me, okay, I know it's not only me, but most times, before you use somebody's function or something, you must actually know what is going on inside, or you must know it. You must have a documentation.
Yeah.
Most times you might not. So most times you might not see any documentation. You might just see you say use this function. Maybe in the future, if I try to generate a random number, a verifiable random number now, and you are so confused. Now you just have to look and read the function now to know, okay, yes, this was going on. And it's now giving insight on how to use it. But for now, this RC20 is not going to hinder you. This one we are doing now won't hinder you.
Okay. Okay.
Yes.
Okay. All right.
Yes.
All right, sir.
But in any way, you might just try to check
No,
what's
I was
inside.
no. I will still go over the video, you understand? But for now, I've not gotten to that part of the last week in class, you
Okay.
understand? So that I'm just asking. But for sure, I will still go over the videos. I'll still practice them.
All right. All right. Let's go.
All right. Thank you.
So let's find out. Now we're going to find how to use a component in our contracts. And the next thing we're going to be doing after that is writing our own component. And did you know that you can use a component inside a component? Yes, I know most of you must have used it or not, but if you write a component now, you can use that component inside another component. It must not be inside the contract. It can just be inside another component. And it might just end there. Then maybe later on you can. Yes, and that component now it would be very nice if all the functions there maybe are internal functions. If you are not using that component in your contracts, you might not write an API on it. That one is further notice. So right here, over here, you see your ERC20. I don't know if you can see my screen. Let me. I don't think it's ERC20 years. Using that link I sent to you. So if you are seeing the link now, you can go there and do what I'm doing. Just like I said. Right now, you have to do what I'm doing. And I hope you have created your what's wrong, Prince?
No, I'm good. I'm good. I'm good. I'm just reacting to what Thomas said.
Okay. She's not wrong, Sha, but okay, sharp. Yes, so we are going to just do what I'm doing, or maybe later on you go back to the recording and check it out. So this is ERC20, and this is the usage. So this is your what you're going to do is just copy it, right? No, you know what this does? You know what this does? Who can tell me what this who can tell me what this thing does?
Well,
It imports the this thing that you want to bring in now.
No. You should note that I'm not writing anything inside this live.cairo. I'm just writing the.
yes, it allows you to actually use the ERC20.cairo file to write your program. It's like what can I say, an import or an insert of that file into the main one.
The live. Let's say that they told you that
It's
Starknet
making.
contract. Sorry, you can speak.
I was trying to say is making the ERC20 file public and available to that lib.cairo.
Very good. I suppose that should something. So I'm going to give you something very good. They'll tell you that Cairo language has just one entry point. Yes, which is the main function, and Starknet has entry points, which is the function. But I tell you, there will be no entry points if I think once the compiler, if the compiler wants to read your program, it enters through the live.cairo. And if something like this now, if you have a file here and it's not exposed, the live actually just exposes it. If it's not in this live.cairo, the compiler won't even know what they're talking about because it actually enters here. That's why most of the codes you wrote it here and it's run back. because it's actually the live.cairo. It looks into there to see what's happening. So if it enters the live.cairo, it sees this ARC. It then enters the ARC and checks what's up. So that's just basically what live does. So anything you want to expose to the contract. So if you're SC, you're writing a code now and you don't like the code or the code is on hold, you can just comment it out. How long was I out?
Very long.
What?
For quite some time.
Okay, sorry about that. MTN, nice one. 7 minutes. Maybe I should have even finished coding the contract by then. So I'll just push it and say we should go and check it out. Yeah. So can you see my screen now?
Yes, yes, we can see the screen. Can see the screen.
All right, let's start. Check that. Seriously. Can you see my screen? Yep. Okay. So what I'm trying to do is remove this bleeding from my screen. Yep. Can you feel this magic? Anyways, please, I hope you guys follow what I just did. Hello. Am I talking to my? Can you hear me?
Yeah, we can hear, but I don't think nobody actually was able to follow you.
Have you gotten to this website? This is the website here.
Yes, the Openzeppelin website. Yes, are we there
Yes.
now?
Are you there now?
Yeah, we are there. I think we're all
Yes,
there.
yes, sir, we are there. We are on the
Yes,
website right now.
So here now, you have this thing now is a token they have written for you. They have written the token for you over here.
Okay.
Yes, all what you have been writing for last week is already here already. So what you have to do is just copy this and paste it in this new file it's here.
Yes, I think we've done that now, but you have
should bleed.
some blood. Yeah, it's bleeding all over.
Yeah.
So you need to use some.
So you have to do some. You have to do some. See imports. You have to import the library. We are using an external library. So what you're going to do is add this line over here. Add it to your list of dependencies.
Okay.
Have you added it?
Yes.
Yes. See all the can you see all the versions here? See all the versions here. So
Yeah, the version is 0.19.0, right?
yeah, that's what I'm using. You can use any of them here, but I use 0.19.0. So your Scarb should resolve. Your Scarb should resolve, and your bleeding should stop.
Mine is not stopping. Still bleeding.
Hello, sir, Mr. Pascal.
Yes.
Actually,
Can you hear me?
yes, I can hear you. I copied and pasted the code on my my VS Code and the ERC 20 file. So mine is not showing any mine is not bleeding. It's just normal. I don't know.
Your Scarb is it resolving? This thing is it yellow? This is
My
it yellow?
Scarb, no, it's not yellow.
I mean, your Scarb is not resolving. I think it will be an issue we will handle after the class. That's if you want to handle it.
I would want to handle it now.
Just I don't know, it text me. I mean that group chat.
Okay.
We can handle your issue at this so that your Scarb can be resolved and you see where your errors are from. Now, Lamin, over to you. You have to.
Yeah, but I don't know what is happening here because I inserted the additional library in the toml file, and I thought I would have to. Yeah, but now we have to come back in here and do the insert. The use Openzeppelin on top of the not. No, it's not resolving. That's weird. It's saying use. I can see that it's using
Can you see my
it.
screen?
Yeah, I can see your screen.
Check this.
Okay.
Your own should be an underscore, right?
Yeah, it's another score. Okay, yeah. Right.
Just change it to this first.
Okay.
In other versions of Scarb, the underscore would have worked, but this new version of Scarb I think for some reason you have to check.
Okay. All right. Now it's resolving. Now it's clean. Thank you.
Yeah. So you have made your token. So it didn't even take up to 3 minutes, right? So that is how fast it is to make meme coins. And do you have any other questions? Maybe later you can customize your, maybe privately you can customize your token and maybe deploy to Sepolia. Check it out. I will send, I think you can send some of your tokens as test tokens. Oh, do you have any questions on what I just did? I know it's not only I mean I should have done this now. Maybe some other people.
Please, can you show that method using resolving the error again?
This, you mean this?
No, when I pasted the code I copied from the website, it's just showing error. So I
And
did not
yes,
really follow along that time we're directing Lami.
can you see my screen?
Yes.
Go to your Scarb, this Scarb.toml file, and add
Okay.
this to your dependencies.
Okay.
Hi. So can you hear me?
Yeah, I can hear you.
So my scarb.toml file is showing all white, like everything is just white here. Is it the extension I'm using, like my team, or
Okay, you want it to like it like my own. You like my own.
Mhm.
Mine is colorful.
Not really, but I think it's better like that. Everything here is just white.
And you have to install one
Yes.
extension.
Yeah, same with mine. Mine is just white, no color at all. Just white.
Yes, that's how it should be actually. But I like colors, so I have to install an extension so that I'll know what I'm doing. You get. So you can, I
So
don't know which extension that is installed.
so what's the extension, sir?
Let me check. Yes, see the name of the extension. Can you see it?
Yeah, we got it.
Yes,
Yes,
so
let me check.
you can make your own color. So I don't know. Is he just Choma Lamin Moses? No, Martin. Martin, hello. Hello, Mr. Martin. Or maybe he's asleep or something. Mr. Caleb. Okay, so I
Okay.
think I
Yes, once we've done that, what next? Because I don't think we can deploy it like it is at the moment. But first of all, it starts like a smart contract, but this is not a smart contract, right? This is a component that you're trying to do.
no. The order of the day was to use a component that somebody else has done for our
Okay.
smart contract. And after that, you try to write our own component ourselves and use it in our own smart contracts and use it in our own component. So what we're doing now is using another component from Openzeppelin inside our smart contract. And here, they just give you a template here. You can customize it. As you can see over here now, this is a contract.
Okay, all right. Okay, it's not complete because you cannot be deployed like that.
Yes, this is a contract already. They just give you an example. You have to go, you can still customize it.
Yes, okay, all right, got it.
So it's a template.
Okay.
So now let's explain whatever it is they did here. Yep. So this is your contract now. And you, of course, you import your components like this. I don't know whether they taught you the file structure, but you can actually import. You can write a component in another file, in another computer or something. But you must just find a way. The end of the day, the end of the link, the what's linking this your project. You might write a component in another project, in another file on your system. How to link that file now to this project now is what I'm going to add as your dependencies on Scarb.stock. Different trick, maybe next class I'll talk about it. Where we are right now. But for now, let's just focus on what's written here. So we use Openzeppelin token from the Openzeppelin website. And of course, if you go back to the website, you see that they showed you one or two things here. They give you the usage. Most of the times you're using the docs of many things. I know it's not everything that will be taught to you. You have to just go to the docs and see how to manage it. Yes, this is the interface of the ERC 20. Most times you just copy it and paste in your interface folder. Yeah. You can create a folder here and copy it interfaces. You just copy and paste it, which I'll call bad code quality actually, because you can actually import the interface from the same. Let's check it out.
Sorry, Tutor, can you hear me?
I can hear you.
So like the contract is actually bleeding, but it's not on your own laptop. Why?
What? My contract is bleeding.
Like the contract is mine.
Okay, yours is bleeding.
Yes.
Check.
And yours is okay.
Oh yes, mine is always okay. It's normal, like saying fire is on or something. But now your dependencies now. Have you checked? Have you put this?
Put what?
Hello? Open your Scarb docs.
Yes, I have.
Then check out. Check out this. Can you see my screen?
Yes.
Okay, see, check. No, now what is this? Check what I'm highlighting on my screen. Check what I'm highlighting. This your own should be an underscore.
Okay.
What can you see on your screen?
What are you highlighting?
No, Scarb. Okay, wait. It should be from Scarb.
Okay. Go back to it. I think I'm seeing. Yes.
Can you see it now? There's your own should be using an underscore, but Scarb.
One second, I'm coming.
Yes, mine has stopped bleeding.
Mine has underscore. Yes. Mine has underscore.
Yes, change it to to whatever this thing is, colon or something.
Oh wow.
Magic.
Thank you.
Don't ask why. You don't ask how magic tricks are done. So let's go on. But in the so in the past, that should have worked in the past. I don't know why they have not updated their docs, but the new version of Scarb will require you to change that thing whenever you copy and paste. So this is just this is what you should have known, that is not everything that you copy that you just paste. Most times to work for others, but it is work for you. So let's go. Now we have this. Yes, I was trying to do something for. Yes. Can you see what I just did? Most
Yeah.
times when you are using, yes, so you don't have to just basically import everything. Unless it cannot be imported here, then you can now start finding out. Because even on this documentation now, they have their GitHub over here. They have their GitHub repo that you can actually see every single thing that they implemented. So the one that I did last week now, if you go to their GitHub repo now and check under their components, you see that they did it. So they have written the interface for you. They have given you the components. So all you just have to do is import it. But I think for now we are not using the interface, right? The only time you might use this interface now is when you want to test your contracts. Testing your contract will be something you are going to learn in the future. So now, to write a component now, once you have written a component, you import it here. You should basically have this stuff here. This thing is just a helper function. So you have this keyword component, part storage and events. This storage, the name of this storage, all these things are parameters. This part, storage, and events. The name of this storage here, as it's 20 now, should rhyme with what is inside your storage strings. So this ERC20 now should rhyme with this. And yes, I'm going to write sub storage vnops. You're going to write this too. They say in the future you have v1. I think this will name their Cairo devs, the people that made the whatever, just to name their this thing based on the certain version number. So this sub storage is just basically telling the compiler that inside this storage there's another storage inside here. You understand?
Mm-hmm.
Wait, you understand, right?
Yes, sir. Yes, sir.
Okay.
I don't understand.
Okay, where do you want me to repeat now?
From what you did in this documentation,
Sorry, what did you say? What I did in the documentation.
yes, I was not really seeing that time.
Is it over here? I will just
And I thought
explain
you
it.
were writing something. You were writing one use on Zeppelin something.
Oh, yes, I just deleted it. But I'm just trying to tell you that, you know, for you to have a contract, no, let's go back to components. For you to have a component, you make a component and you make an interface of the component. So if you are going back to our, I've kind of deleted it. If you go back to that slide now that I sent on this message now, and check components, you see that the components API actually implements a trait, and that trait is actually an interface. Yes, so that is what this Openzeppelin component did. It implemented a trait, which is an interface. And now it implemented the trait now. All you did was just to import the components now. But there's no how you can use your contracts without a dispatcher. And that dispatcher now is only found on the interface of whatever. So you have two options. One is to go over here and copy this whole interface now. You get? Are you understanding me? Before you can use your contract, you need an interface. Whether you
Yes,
like it or not.
yes,
Can you hear me?
yes, I can.
Yes. Yeah, I
Okay.
can hear you.
You should put it in the back of your head that before you use a contract, you must have an interface. You might see a contract that does not have, yes, or some people write contracts, like this one, somebody that wrote contracts for me. I never imagine someone, you wrote a contract without an interface. Yes, it's possible actually. They have use something like API per item. I don't know if you have seen that before. You use generate traits. Maybe I should I write it? Should I code it? You do there's one using this API embedded within us. That is one for exposing your API actually. The one that you guys used last week. Now they have another one that you have to generate traits on that spot. There are two ways of making an implementation. You write the traits, then implement it. Then there's another one that I don't know if have you seen this keyword before? I've seen this before, right?
Yes, absolutely.
Yeah, so basically you can just write of and it will basically generate this trait for you. Yes. So you can also do it like this for an API. You write what's the keyword? API per item. Something like this. Although nobody uses this. Because now if you're writing your contract now with the API like this, and you write that external Venus, nobody will have an interface now to access your contracts. So now what people use now to access your contract now is to this works. what people use now to access your contract now, you have to like start reading your contract. They start writing their own interface of the contract. So they'll start writing hard coding. I don't believe that if somebody has written something before you, so start writing it again. And writing this kind of thing now for your contract I think this is meant to be outside here. This is meant to be outside here. But I think this kind of thing now for your API, I don't think it's possible, but it's very bad code. I don't know if is it code convention. Because now, once I'm writing like this now, I'm just trying to say that somebody will be able to use it until they write their own personalized interface of your contract. So now, just like them now, they did a separate interface and a separate implementation. And now the components implemented the interface. But now you have put the components in your contracts. You can't use the contract without that interface. And they know about this too. So they gave you the interface here. And of course, you can actually copy it now. You can copy it and paste in whatever interface folder you have here. But then, let's say you are modular like me now. I don't like too much code. So you can just, they made it possible because they have sense. They made it possible now that you can also import the interface. With Choma, hello?
Yes, I am.
Okay.
Yes, I am. I can hear you.
All right. So you can pick this. You have two choices here. Some people would love to just copy this and paste it somewhere in their contracts. But now you can also import it. They have made it importable for you now. So as you have imported your component, you can import your I hope your own is working like this. It's showing you all this stuff. So you can import it like can you see it now? Can you see your dispatcher?
I'm coming. Mine is not bringing all those options, so I'm just writing.
Okay, just right now. Just write what I wrote here. Should give you something like this. Please, I'll come back to you. I saw your hand. This.
Oh, sorry. It was my mistake. I can see it now.
You can see it now.
Yes, the interface. I started the I wrote capital letter, so that was why. Thank you.
I see. So now, if you think hard or you think little like me now, you will see that you don't need interface to do anything actually. Yes, just look at it. You are not using it to do anything unless you have another contract. I think we taught you about cross contracts, right? But now we are not writing another contract because I'm trying to explain what this contract, how this component works. So unless you have another contract now, you may import this component. This you see this is the dispatcher now. You won't import it here. You import this dispatcher in the other contracts. I am going to use this dispatcher now for this contract. Am I making sense?
Yes.
Please.
You are.
Please, you can speak. Sorry for.
Quick question. Can you write the interface and the contracts in two different files and then import them together as a component, something like that?
You should know one thing. One thing is that the interface, as you can see, actually, plus the one that you wrote and plus the ones that these guys wrote, the interface always stays alone. You don't combine it together with anything. It just stays on its own. It serves like an entry point, or let's say a face for the contract. Like, how are you going to interact with my children without interacting with me? that kind of stuff. So you can't interact with the contracts without the interface. So in the interface is always a loop. So you cannot like combine it. Or even when you're writing your component now, you write your interface in a separate file. It always stand alone. It's not as if it's just a separate file. I think everything you have written an interface before, and you actually saw that you wrote it first before writing Starknet contracts. So the interface is always alone. You can even shift the interface now. You can delete it and put it in that file. All you have to do is just import it. Going to import it. And what is importing it now is the contract that wants to use the contract that implements the interface. I've spoken too much. Oh God. You see how I'm combining this English. I don't even know if I'm saying the right thing, but I'm very sure I'm saying the right thing. Please, can you hear me? I don't know if I'm answering your question. Maybe I can break it down bit by bit.
I get what you said. I get what you said.
Are you sure? You can always ask, though. Not that I'm not. Okay, so let's continue. In case you have any other questions, maybe we are practicing this on your own, you can always ask in the chat. I always answer actually. So as you can see, we are not using this. You use this if this was a contract. You should know when to use this, right? You can't use your dispatcher in your own contract. You should use it in another contract or something. So let's compare this out actually. Yep. So like I was saying now, to use a component now, you have to use this component function. How you are going to import it in your React library. Yes, you import it here. You make use of this use statement here, and you declare it as an input as a component. You don't just bring in the file where the component is. You have to declare that yes, this is the component. And you have to, it carries three parameters. This component macro. It carries the path of the component. Actually, you can write the whole part like this. You can like this part now. Why we are writing it like this, like just ERC20 component, is because we have already imported it here. If, for instance, we didn't import this now, we have to write this whole part now. We have to write it inside here. But of course, they look somehow. If you're writing this whole part inside here, this whole part inside here, just put the whole part here. Put this, what you label as component. In good coding practices now, you have to name your components actually. Yes. So that you know that yes, it's a component. What's shining red here? Oh. Yes. So there's a component now, the path, storage, and events. The storage now, the variable path in the storage parameter must resemble what you have in the storage here. Are you getting this? So this is ERC20 now. Don't use something like this. If you see something like this now, then this should be this. You understand it, right? Then your events should this events now should and something that you should know now is that in these V notes, maybe in the future they'll bring out the V1, or in this V note now, this is the storage. This is the storage of your components. And of course, I know okay, yes, I think they are showing you something. Yes. Can you see can you see my screen? Can you see the storage that is inside the component? here. This is the component. This is the storage that is inside this component. Now, for example, now you have, can you see this? You have this.
Yes, sir.
Yes. If you should reply me, please. You have this. You copy this now, and maybe for some reason now you want to have a storage here. Let's say fields 252, right? Now, do you know that there's a conflict? Because now this sub-storage now tells the compiler now, it tells Starknet, the contract, that there's another storage inside this storage now. But then this storage now, this is just formality. This thing now just basically brings everything here now. This whole thing, you see this whole thing that you are seeing here now. It brings it inside this storage here. Forget this thing you are seeing here. It brings this whole thing inside here. So if you're having two things like, if this storage now is an ERC20 name here and the same name here now, use it here, there will be a conflict. I don't know what they call it. That is a security issue, actually. So when you're interacting with your contract now, you won't even know what's going on because you named one of your storage variables something that was already named the component storage. That is the flaws of nodes. They said when V1 comes out, that thing can be cleared, but it does not come out yet, so you have to stick with this. So no matter the course, we are going to use a storage now. Because I use any of these names that are already here. Am I clear? All right, sharp. Now, moving on from the storage now, we go to the events. Yeah, events. This event you see over here now must be the true model of what is here. No, you can't write something like this and expect it to work. It can't work out. Just have, once you write something here, just make sure you take chances. Just don't even take chances. And you pick up your the 20 components, then dash shall be colon events. Yes. How to show it that yes, the events that is here. This flat means something. Flat is what they call it in respect. Now you can use the word flat as yes, it flattens this event. This event has something actually. It has transfer events and it has amplify events. I know you wrote your ERC20 and you saw that. I don't know if you wrote transfer events or approval in your own ERC20, but it has this thing now. Just like your storage, this thing now, this event now comes here. It appears here. Forget this whole thing. It appears here because of this flat. This flat now, there's the storage. Sorry, this flat, there's the contract. Look into this event and see what is inside this event. It's like an introspect, like I said. You see the chain of command, right? It enters this event and sees this event now. On a normal, the contract now should throw this event as it is. Look for whatever is there, but you can't see this event, but it exists. For some reason now, you want to access what's inside this event now. You need this flat. I don't know if I'm present. I don't know if just take it like introspect. You can check what introspect is on. Honestly, I didn't know what it meant until let's see 6 months ago. That's that. So yes, that is your events. You have events, you have storage. Now, what I'm going to talk about now is this. This is the main part now that to just make everything just do somehow. like you are seeing ABI embedded VNOT now. Then you see this kind of thing. This kind of thing actually exposes this thing now. This you see this is a function, or this is an implementation now that exposes an API or something like an API now to whatever contract that is going to use the interface. That is going to use, sorry, that is going to use the component. So, and this API now, this thing now only works for this first line. And this one, it does not mean this one is a different thing on its own. This is an internal function. Oh, this is an internal function. What does this mean? This internal function now, it just means that you now, as a user now, or as a front-end user, could not interact with this function because it does not have this API on it. For instance, you want to interact with it, it's fine and good. You can put I don't actually. I don't know if it's going to actually work. But you see the internal structures of the components, which cannot be done today actually, because I think we have like eight minutes left. Cannot be done today. So that's just it. But just look at this well and see that yes, this is how we are going to expose, and in everywhere you go, this is how you are going to expose the API of a component. This now is an implementation in the component. Yes. And how you are going to get this implementation is by using the component's name, colon, implementation, the right contract state. When you're writing your own component now, you see that, or you envision that, okay, yes, it's far different from, it's the same thing as a contract, but the syntax now is different because you start hearing component states, T contract states. Just it is that I don't actually know why they use it like that, but that's just how it is. You have to make it that way. So this is an internal function, and you have to bring it over here now so that your contract now can use this function. Yes. So now, if you want to read any function actually, either from this implementation of the API or the internal function, to call self dot the storage variable, storage name dot whatever function is inside the component. Any questions? I know there should be questions, but I don't know. Any questions? Wait, no questions. Wow. Must be a good one. Since I've broken it down for you guys, right?
So I'm a bit lost from the implementation. So I don't really know if I would say it's a question or
Where did you get lost, please?
From the
the API?
implementation. Yeah, from the implementation. Yeah, from the ABI itself. Yes, from that place.
Okay. Now the API now, this is how it is exposed. This API now only covers for this. Yes. And that if you actually understand what this means, once you write your own component. But for now, this is how to expose any if you know any component at all, this is how you are going to expose it. So far it is Starknet. There are no two ways of exposing the components. This is the only way. The only thing that may change, of course, is the name of the components. And I don't know if they can keep another name. Right? Yes, you can name it anything, I think. But you must give it equals to the components. You know, if you're writing your own API here, named 20 API, something implementation. Then you now equate it now to the component implementation. See contrast state. I don't think there's any explanation to this. Just once you just reach this part, see, okay, now I've reached the part I want to expose my components API. Just go and look for one repo, and if you see this thing there, just copy like this, Control C and paste it. What I'm going to edit now is the name of the components. Of course, it must match with what is here. Then the name of the implementation of your component. Then you write the contrast state. So that's it. Then after that, I talked about this is internal implementation. They are all going to be used by this smart contracts. This is going to be used by anybody calling this contract. This API exposes this, but this remains internal now, just for this contract. Yeah, and what I said again was to call any of these functions, both this and this. You must call self dot. There is a storage there, the storage of this component. You must call this storage. Don't worry, it works like magic. You call this storage now, ERC20 dot, and for some reason all the functions just choose after you call self dot the storage of that component. Once you call self dot the storage of the components, all the functions under this implementation, both this and this, sure. Even storage variables. So you can call self.erc20.erc20 name. Yep. So that's it. I don't know. I think I don't know if I'm answering the question.
Yes, I understand now. Thank you.
All right. So I don't know, any questions? You should have. Am I that? Or maybe you guys are just okay. Okay, I think like since there are no questions now, so I think we're going to our next agenda actually, what you should be expecting. I see that you have class tomorrow, so what you should be expecting next tomorrow is we have made our own contracts. And we are going to no, we have not made our contract actually. We use that business contract to use another business component to put in our smart contract. Now, what we're going to do next class is make our own components and explain why it's made like that. So I think that's all for today. Good night, guys. See you on Wednesday.